So, by about the late 19th century, people had figured this paradox out, and experiments were done. The most famous of which is the Michelson and Morley experiment, to actually see if the speed of light was constant, even though the Earth was moving. And the answer came back that the speed of light did seem to be constant in every direction. Whether you measure it along the direction, or back, or sideways.
That's crazy, Paul. So we're moving in this direction, and I measure the speed of light that direction, and I get the same answer as that direction? It's like light seems to know what to do based on what I'm doing. That seems impossible.
Yeah. Well, it makes sense if the Earth is stationary. Because we've now found a universal frame of rest, and that frame of rest is the Earth. The Earth is stationary.
So the Earth isn't rotating once a day, and it's not revolving around the sun?
Well, no, maybe Aristotle was right, and the Earth is stationary, and the sun really is going around us, and we're not rotating, it's the universe that's rotating around us.
Okay, I'm not feeling better about this.
What else can we do? I mean,
well,
the speed of light seems to be the same in all directions.
So maybe there's some weird way that light travels in an ether, and although the Earth's moving, the ether isn't moving. Would
or it's
that
moving
be
with
possible?
us. Yeah, so back then people thought that we know that other sort of waves, for example, water waves move in water, sound waves move in air. So maybe light waves move in something we can't quite see that was called luminiferous ether.
Right.
Which means that thing what makes light waves happen. I guess it's the dark energy of its time.
Absolutely. So you would have this ether be moving along with the Earth.
Yeah, so the Earth would have to have a chunk of ether around it, which I've coloured in this light blue over here. And the idea would be that that was following the Earth around in its orbit, which is why when we made measurements here, the light seemed to travel at the same speed in all directions. But if there were any astronomers on Venus or on Mars or the Sun trying to do experiments, they would have their own chunk of ether around them, and they would also find themselves at rest. So this gets away with the horrible problem of the whole universe rotating around us.
Okay, but it does mean that if I look to here, that there's going to be a different piece of ether here and a different piece of ether here, where light travels at different speeds, presumably. And I know that if you change speed, for example, if you put something in water where the speed of light is slower in the water, you get these refraction effects, and so that you end up seeing two images, or you see light bend, and very useful for making a lens, but it's not, it means Venus is going to be distorted and things.
Yes, people did the calculations, and if there were a chunk of ether following the Earth around, another chunk following Venus and the Sun and the galaxy and so on, that would explain the Michelson-Morley experiment, that the speed of light was the same in all directions. But we'd then start getting horrible effects whenever the light went through these ether boundaries. Right. The alternative would be that the ether for the entire universe is centered on the Earth and following us around the Sun.
And that violates the Copernican principle that we're not a special place in the universe.
That sounds pretty crazy.
Right. So we have another paradox.
A different version of the same paradox. So it doesn't look like we're moving, according to the experiments. The light's doing it at the same speed in all directions, but we know we're moving. So what the hell's going on here?
So, I don't know. I think we're going to have to think harder about crazy ways to fix this problem.